Welcome to Math 2318. This is section 4.7 and we're looking at change of basis. So we have two bases here. We have basis B, B1, B2, basis C, C1 and C2. Now basis B relative to the C basis is given by these two expressions. And so what we have is B1 relative to the C basis is minus 3,9. And B2 relative to the C basis is 7 minus 6. So we're looking for a change of coordinates matrix going from B to C. And so what that is we simply take those column vectors on how we transform, and they go as columns in our particular matrix. And so the question is then, all right, supposing we have an x relative to the B basis, we'd like to write x in terms of the C basis. All right, so we simply take our matrix, our transformation matrix, multiply it by x in the B coordinates, go through the multiplication, and then we get our representation of x relative to the C basis. All right, in question 2, we have an A basis and a B basis. All right. And so we represent each of our A's in terms of the B basis. Okay, so we get those column vectors. Our change of coordinate matrix then going from A to B is simply put those columns in there. And so now, how do I go from an X in the A basis to the X in the B basis? All right, so I simply take my X, 4, 5, and 1. So 4, 5, and 1, that's X relative to the A basis. Multiply it by our transformation matrix, and I get x relative to the B basis. So it's change of coordinates from A into B. All right, in question 3, we are given two bases, B1, B2, and C1, C2. We want to find the change of coordinates going from B to C, and then the inverse of that going from C to B. So to find this transition matrix, we row reduce, putting our C1, C2, B1, B2, and row reduce it in our matrix. Alright, so we do that using row operations. Use the 1 to make a 0. Divide through this row by minus 1. Use this one to make a 0 above it, giving us our transformation matrix going from the B basis to the C basis. And then to find the inverse, well, to get the inverse, we need to find the inverse matrix. So if you remember from what we did previously, let's scroll back up. If I have a 2 by 2 matrix and I want to find the inverse, it's 1 over the determinant of the original matrix. A and D switch positions, and I get a minus C and a minus B. And this works so long as it is invertible, meaning that the determinant is not 0. Alright, so when we do that, the determinant is actually 1, right? Because I have 36 minus 35 is 1. And so A and D switch, nothing happens, and I get the negative of what was there. And so this is our inverse transformation going from C back to B. All right, in question 4, we want to find a change of basis where in P2, the set of polynomials of degree 2, we'd like to go from this basis to the standard basis. Well, remember that the standard basis looks like 1t and t squared. All right, so, well, if I take my basis vectors in B, what would they look like in the normal bases? All right, so let's see, I have 1 minus 4t squared, so a 1, 0, minus 4. All right, so I do that for all 3 of my B vectors, representing them in terms of the normal basis. All right, so our transformation matrix would look like that in terms of the columns. And so they want us to represent something in terms of our C vectors in terms of t squared. Well, t squared in C, this is the normal basis, would be 0, 0, 1. I need to figure out what would it be relative to the B basis that they gave us, which means I need to solve for that. So here's my transformation matrix. I'm looking for this relative to the new basis, and this is it in terms of the standard basis. And so we do our row operations, and when we do the row operations, cleaning this all up, I get that in terms of the new basis, it's 11 minus 3 and 1. And so that's how t squared in the old basis would now look relative to our new basis vector.